Do you want to try a little experiment? What's the difference between noise and annoying noise? Is it the level? Is it the frequency? Where's the threshold? Let's find this out. I have a drum here that obviously can make some noise, and you can listen to that because you can listen to the binaural recording, and I have an online view of Artemis, so I get all the data we need. I play a file. Let's see, where is your threshold? You say, okay, now it's getting painful to my head. Okay, ready? Let's see where this leads us. God, sorry, 2 more missing. What has just happened? I played a rhythm, and you say, oh, and there's 2 missing. This was the annoying part. The pattern that you recognize was not continued the right way, and this gets you here. It's not about the level. I can play it soft. Please, 2 more. I can play on different frequency. You have to be 2 more, okay? This is the most important effect talking about annoying noises. Humans recognize patterns, always. And think about how this pattern goes on, and then see if it goes on. And because that is the most important analysis, if you're talking about annoying noises, Head Acoustic has developed an acoustic analysis exactly do this. Looking in the past, recognizing the pattern, make a prediction to the front, and then see an incoming signal, does it follow my expectation or is it a wrong signal? Even a missing of a signal can be annoying, okay? And this analysis, I love, it's full of my heart. Full of my heart, I love to show you this powerful analysis in this tutorial. And the name of this analysis is the relative approach. Bumper. First of all, we have to understand how does the brain work? How does the brain perceive sound? Okay? Simple experience for you. I just play you a song and then I ask you, what have you heard? Okay? Simple. So pay attention and there we go. Okay, stop that. What have you heard? That is the pattern of that song. That is what's in you, that's what you feel, that is what your full attention want on this pattern, okay? Now let's check the analysis for this music. Let's do an FFT versus time, because it's changing. And I add the new analysis, relative approach. There is 3D and 2D analysis. I recommend always to start with 3D analysis to check if the setting is right and it works on that file. And then later on you can say, okay, it's good, I can go to 2D diagram. But first we start always with 3D diagram. FFT and relative approach, default setting. Maybe I get here for A weighting. Yeah, make it like this here as well. And calculate. On the left side we see the FFT, on the right side we see the relative approach analysis, which looks completely different. So in the FFT the main message is of course here between 200 and maybe 500, this is the main energy in that sound file. Okay, so this is important. Let's listen to that one. That's not what I heard. It is. These are the violoncellos, these big ones. This is just background noise. Yes, they are loud. Yes, they are bigger than the violins, but this is not the pattern I heard. Let's go on top. It's exactly what we heard. There is the music playing. That is the pattern of the song. There are dozens of instruments in this orchestra, but all we perceive is this pattern of this noise. And every of this pattern, ding ding, ting 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 ting, ting 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 ting, is detected and given a value. Welcome to the relative approach. Probably you will now say, hey, hold on, I'm not working on music files, I'm an NVH engineer, I'm working on engine recordings, something like that. But you need to understand, in the end, it's the same brain and the same ears that evaluate the sound. If it's music or if it's an engine noise, it's the same processor in here, same pattern detection. The reason why we love music is because it has a lot of patterns in there. We follow patterns. We love to have patterns, yeah? But we do not want to have them in any of these washing machine, dishwater, and every pattern just drags our attention and it seems to be wrong. Okay, so that's important to detect the patterns. So the next file I play is an NVH measurement. It has a full spectrum that you hear, and you just have to find out what annoys you in that spectrum. Is there any tone, any noise that say, this I don't like? Okay, let's check this, listen up, and there we go. One more time. Yeah. You have a constant no pattern, and you have tick 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 tick. Oh, yeah. Let's analyze this. So we have the FFT, we have relative approach, and to sort this right, I also add the hearing model as the analysis. I give you a lot of information in the last video, highly recommended. And just add this as well. Put an A weighting on it so everything is the same. So on top we have the FFT, then here's the hearing model, and below it's the new analysis relative approach. Okay, we start on top. You see the most of the energy is here 100, 200 Hertz. This is already A weighted. The way as the peak, let's play it. This small fella is the most important information we get from the energy relating FFT analysis. Too small, too tiny, too short, neglected. Yeah. One step further, we go on hearing model, and we see here now, yes, there is a lot of energy. We can hear this broad noise, but important is this. Are these analysis. So the pick out, this is for human brain importance. Now we go one step further and go with a relative approach. We make it always clearer in its color. We can see anything that doesn't change at all, which doesn't have a pattern, is quite down in this level. The only important is another example. Now we take this recording, now otherwise around. First I make the analysis, FFT, hearing model, and in the end relative approach, okay? As you can see in the beginning, there's never a result because the analysis just listens to the file, recognizes a pattern, and then say, okay, it has to continue this way, and then compare it that way. If it follows a line, it's fine. If it's up or down, it's not that what we expected, then it's an error and it's highlighted with high colors here, okay? So what I see here, there is some noise, there's some a lot of noise in there in all directions. Here model tells me, hold on, there's a lot of tack, 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 that counts. That is the most important thing. And here you can actually count every time there is a disturbing noise, and you can see how big the disturbing is. Let's play this. You can see the pattern. This noise is not loud, but it's just a hook in the brain. Listen, 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 I'm here. I'm disturb you. Up to this point, I've shown you the basic principle of the relative approach analysis. In the second part, I will show you specific NVH applications for this algorithm, and I will show you the possibility to apply this algorithm to specifically certain kinds of noises. This is very impressive. Hence, here the warning beforehand. This is very impressive. You will most probably want to have this algorithm and try it out after seeing that video, okay? But this analysis is only available in the Artemis suite of head acoustics. So it only makes sense to watch the video if you can install the Artemis suite on your computer. If for some reasons you are told not to buy anything from head acoustics, then for heaven's sake, do not look at the video. It would tear you apart. But if you say, hey, sure, if it's good, then I'll try it out on my measurement data, then I recommend to watch the second part of the relative approach. It's very impressive. Have fun with it.